All right, A3. Again, we are finding an equation in standard form for the hyperbola that satisfies the given conditions. On A3, they gave me the foci. I remember foci, it's always the one with the C. And they gave me the transverse axis endpoints. Transverse axis is always the major, and axis endpoints are going to be your vertices. So again, we look for what stays the same. And on all of these, we notice that the second, your y-coordinate is the same, right? 2, 2, 2, 2. Your y-coordinate stays the same. So if I look up at the chart, for the one whose y-coordinate stays the same, I notice that I'm on the blue side, right? The x-coordinate will change on the foci. It'll change on the vertices because I have the plus and minus. But the y-coordinate remains k. It remains the same. So I'm on my blue side, and what they have given me is k. This 2 is k. K, 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 K. All right. On the foci, one of these is h plus c, the other is h minus c. The plus is always the bigger number. Between -4 and 2, 2 is the bigger number, so this is my h plus c, and -4 would be my h minus c. Okay? In a similar fashion, I said the transverse was like your major, axis endpoints, the same were your vertices. Those are your h plus and minus a. Again, the plus is going to be the larger number, so 1 is bigger than -3. So that's my h minus a. I'll just start with the foci. Why not? They gave it to us first. And I will set up my elimination problem. So h minus c is equal to -4, and the h plus c was equal to 2. Okay? So we will add these two equations up. H plus h is 2h, the c's go away. -4 plus 2 is -2. If I divided both of these by 2, my h would be -1. Then I remember I always have to plug it back in. I like to plug it into the plus. So I have -1 plus c equals 2. Okay, and if I'm solving for c, I would add 1. Plus 1 plus 1. C equals 2 plus 1, which is 3. Okay, I could set up elimination here, or I could just take the fact that h plus a equals 1, h plus a equals 1, and use the fact that I already know what h is. Since I already know that h is -1, then -1 plus a equals 1. And I can just add 1, and a is 1 plus 1, or 2. Let's see, I've got everything I need but b. The reason they gave me c is because I have to use it to find b. The way we do that is the Pythagorean relation. So the Pythagorean relation for hyperbolas is the same as the Pythagorean theorem for triangles. It is c squared equals a squared plus b squared. Okay, we'll plug in what we know to find out what we don't. C squared would be a 3 squared, right? Equals a squared, a was 2. So 2 squared plus b squared. So 9 equals 4 plus b squared, which, if I subtract 4 from both sides, I find that b squared is 5. And that's fine. We'll stop there. We do not have to square root it. I don't need b on its own, because b squared is actually what is used in the standard form, which is what I'm going to write now. So x minus, and then we have a y minus, and the squared equals 1, and I will just fill in my blanks. So with the x is always the h. The h, ooh, wrong color. Y'all know how I feel about my colors. All right, the h was -1. So if I subtract the negative, that'll be a plus. Along with the y is always the k. The k was, what was the k? The k was given to us in the beginning. The k was 2. k was 2. All right. In my denominator here, I always have a squared first. And a was 2, so 2 squared will give me a 4. And down here will be my b squared, which is 5. It is not 25. Please don't square this. It's already squared. This is just a 5. All right, and that is a 3.